All right, these are problems 1 through 5 on review day 8. The first one gives us a limit, and anytime we have a limit, we should always plug it in. So if we do that, we're going to get 0 on the top. We're going to get 1 minus 0 minus 1. We're going to get 0 on the bottom. As soon as we get 0, 0, we know we got more to do, and the more to do almost always is L'Hopital's rule. And L'Hopital's rule says take the derivative of the top, which would be 8x, take the derivative of the bottom. That'll be e to the 4x times the derivative of 4x, which is 4, minus 4, and then that goes away. Try it again. When we try it again, we're going to get 0 on the top, and we're going to get 4 minus 4, 0 on the bottom. L'Hopital says, don't worry, don't freak out, just try it again. So if we take the derivative of the top, take the derivative of the bottom, we end up with 8, and then this is going to be 4e to the 4x times another 4 that pops out, so it'll be 16 here. When we try it this time, we're going to get 8 on the top, 16 on the bottom, so 1/2 b. All right, so just have to be a little patient there with L'Hopital, but it gets the job done. All right, the second one here says g is a twice differentiable function, and it's an increasing function. G of 0 is 20, g of 10 is 220. Which of the following must be true? And they give us something about the derivative and the second derivative here. So some interesting, some of these things make sense, some of them don't. We do know that it's a differentiable function, so therefore the mean value theorem would hold, and that's kind of what's being implied here. So let's find the average rate of change. 220 minus 20 over 10 minus 0 would be 200 over 10, which is 20. So the average rate of change is 20. Therefore, there's somewhere the derivative has to equal 20. So first part says the derivative has to equal 0. No, that's not a guarantee. The derivative has to equal 20 for some. Well, that's what the mean value theorem says. Let's just read on. The second derivative has to equal 0. The second derivative has to be positive. No, we're not guaranteed that it has to equal 0. Now, the second derivative has to be greater than 0 for all t. That one's a little sneaky because it tells you it's an increasing function. So the derivative has to be positive, but not necessarily the second derivative. So you could get a little caught there with that increasing to think that D is true, but the reality is B is our answer because of the mean value theorem. See, I had to do a little double take even right there to make sure. Now we get this one, we're taking the derivative of an integral. Anytime we take derivative of an integral, what's this going to cancel? The rule is you take this and you drop it in. So it's going to be natural log of x cubed squared, which will be x to the 6 plus 1. So you could get excited and go for a, but the thing that you have to remember is that we also have to take the derivative of that. So we have to take the derivative of x cubed, which is 3x squared, which tags this on and makes the answer C. So don't get too excited on that one. C is our choice. D looks tempting with the E, but E is a number, and so anytime it's a number, it's going to go away when you take the derivative. So that's why we have to do it that way. Number 4 gives us a slope field, and it says which of the following made it happen, and we've got some different variables. So again, in a case like this, I think it's always a good idea to just come grab a point and see. So if I pick, say, 3, 3, I know at 3, 3, I'm supposed to get a negative. So if I did 3 divided by 3, this would be positive. 3 divided by 3 with this negative sign here would be negative. That's okay. 3 times 3 would be positive. Negative 3 times 3 would be negative, so that's still okay. Then if I were to, say, come over, the trouble now is that no matter what quadrant I pick, when I divide them, or if I multiply them, it's going to be the right sign. So it's really more about, should I be dividing these numbers or should I be multiplying them? So, so to get kind of that idea, I'm going to look at when y equals 0, which is right along the x-axis. And you can see that these marks are 0. So when y equals 0, the slope is 0. Well, that's not going to happen for b, right? If y was 0, this should be vertical lines. So b goes out and d then is our choice. So you could go and bounce around from the quadrants and you'll never get b or d to disagree with those. It's only at the axis points that we have any kind of differentiation between them. All right, and then our last one for 1 through 5 gives us this integral and it tells us what to do a u sub for. This one's one of those sneaky ones where you have to do like a double u sub. At least they don't make us go all the way through. They just want to see if we can get to that other part. So if u equals x plus 1, we know du is equal to dx. And when we do the initial, we're going to get x over square root of u times du. Now this x isn't canceling, and that's the problem. So what we have to do is come back up. We have to subtract 1. And we have to sub u minus 1 in for that. So this is going to be u minus 1 over square root of u du. And if we break that into there, we're going to get u divided by square root of u, which is u to the 1/2, minus 1 divided by that, which is u to the negative 1/2 du. And that's going to be c. So a little sneaky, that little double sub, which we don't do a ton of. But that's how we have to kind of navigate this one.